Welcome. In this e-learning module, I shall make you understand the design calculations related to the stripper plate. We will calculate the stripping force, FST, and the thickness of stripper plate, DS. First, let's calculate the stripping force, FST. The stripping force is the force required to strip the sheet metal strip from the blanking punch. The formula used to calculate the stripping force, FST is FST is equal to 0.1 times the FSH, where FSH is the shear force. Remember, we had earlier calculated the shear force, FSH, as 14.41 tons. Substituting the shear force's value in the formula, we get stripping force, FST, as 1.44 tons. 1.44 tons is equal to 1,440 kilograms. 1,440 kilograms is equal to 14,126.4 newtons. Now let's calculate the thickness of the stripper plate, DS. To calculate the stripper plate thickness, we shall use the formula used to calculate a simply supported beam's maximum deflection, subject to a point load. Delta is equal to the product of FST and L cubed, divided by the product of 192, E, and I, where delta is the maximum allowable stripper plate deflection in millimeters. FST is the stripping force in kilograms. L is the length of the stripper plate in millimeters. E is Young's modulus of steel in kg per square millimeters. Remember, the stripper plate is made of steel. I is the moment of inertia in millimeters to the power of 4. W is the width of the stripper plate in millimeters. And TS is the thickness of the stripper plate. As the stripper plate cross-section is a rectangle, the moment of inertia can be calculated using the formula I is equal to the product of W, and TS cubed divided by 12. By substituting the moment of inertia formula into the maximum deflection formula and resolving the stripper plate thickness, we obtain a formula. DS is equal to the cube root of the product of FST and L cubed divided by the product of 16, E, W, and delta. The maximum allowable deflection for stripper plate can be 0.08. Earlier, we had calculated the stripping force FST as 1,440 kilograms. The length of the stripper plate is 182.5 millimeters. And the width of the stripper plate is 144 millimeters. Young's modulus of steel is 214,000 kilograms per square millimeters. Substituting all the formula values to calculate the stripper plate thickness, we obtain the stripper plate thickness as 13 millimeters. With this, we have successfully learned how to calculate the stripping force, FST, and the thickness of the stripper plate, DS. That's all in this e-learning module. Thanks.